Okay, let's take a look at this question. And I'm back. Are you scared? Anyway, an object is dropped from the top of Pittsburgh's USX Towers, which is 841 feet tall, which is just a little taller than me. That was a joke. Okay, good. All right. The height of the object after t seconds is given by the expression 841 minus 16t squared. That's the height of the object after t seconds. So I'm going to write equals the height. Okay, that's how high it is off the ground. How long will it take? T is time. How long will it take the object to hit the ground? Round your answer to the nearest second. At any rate, here's the deal. If it hits the ground, that means it's not off the right. If it hits the ground, that means it's not off the floor at all. That means the height of the object is 0. So what I'm really trying to solve here is this. The problem is, we don't know how. We don't know how on so many levels. We have never, ever solved any equation that was not linear, where the degree was not 1. This degree is not 1. We do not know how to solve this. We have to learn a lot more information before we figure out how to solve this. So let's get started. All right, this is a little review of what we've already done. If you remember to take square roots of bases with exponents, all we did we divided the exponent by the index that you didn't see there because the index here is 2. So all this is x. 2 divided by 2 is 1, which makes sense because x times x is x squared. Same thing here. Okay, we divided the exponent by the index. So 4 divided by 2 is 2, which makes sense because x squared times x squared is x to the 4th. And that's what square rooting means, right? If we square root 9, we get 3 because 3 times 3 equals 9. And we've done this before. And it's been in the homework 100 times, so hopefully you kind of remember this. All right, let's take a look at then the square root of x to the 6th. The square root of x to the 6th, oh, this is so easy. We just divide 6 divided by 2, and we get x to the 3rd. And then here, same thing. 16 divided by 2, and a 2 comes from here. Square root means that this little guy here, which is called the index, is a 2. So that's keep the base, divide the exponent by the index, and we get an 8. Okay? Here, same thing, x to the 21st. Same thing here, x to the 50th. We do that with exponents, not with numbers. Remember, perfect square numbers might be 1, 1 times 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16. Here's what you might recall about this. Perfect square exponents are going to have to be even because you have to divide them by 2. But perfect square numbers do not have to be even. Some are even, some are odd. You have to say to yourself, what times it's... You got to talk to yourself. The only way to be a good mathematician is to talk to yourself. Okay, so if you're crazy, does that mean if you're crazy, you're a good bet? I don't know. Okay, anyway, square root of 9 is 3 because 3 times 3 is 9. So yeah, that's what you have to think about when you do numbers. But exponents are simple. You just divide them by 2, which is the index. So would you do the next 3 problems in your workbook and multiply those, and then we'll come back and talk about them. All right, here we go. I think these should have been fairly easy because they are, what are they? Yes, conjugates. They're conjugates. So we could distribute, or we could also remember that the middle term drops out, so there's no more oi, so all we have to do is foo. All right, so multiply the first times the first. X times x is x squared, and the last times the last. Negative 4 times positive 4 is negative 16. Done. Cool, I love those. But you have to know their conjugates. If you're not sure, you better distribute all the way. Same thing here. We have conjugates, so we're going to foo. 3c times 3c is 9c squared. Negative 2 times positive 2 is negative 4. Done. Oh, could they all be this good? Y squared times, conjugates. Sorry, I just went so crazy, I knew that. Conjugates, I'm going to foo. Y squared times y squared is y to the 4th. Positive 3z times negative 3z is negative 9z squared. So I'm fluting the whole way through. Now understand this. We asked you to describe these two terms. So every time you multiply conjugates, if you had to fill in this little sentence, every time you multiply conjugates, you will get I'll fill in for you. You will get a binomial, right? These are binomials, 2 terms. But it's a binomial of a special form. This is a perfect square. This is a perfect square. And it's separated by a minus. Is that true for all of them? Perfect square, separated by a minus. Perfect square, separated by a minus. The reason that's true is because when you multiply the first times the first, they are exactly the same. You multiply the last times the last, the number's the same, but the signs are different. You get something like this, and it's called the difference of 2 squares. This is called the difference of 2, either squares or 2 perfect. Some people will say squares. So remember what makes it the difference of 2 squares. Okay? Perfect square, binomial, perfect square, separated by a minus. That's in your workbook. So for the next couple of problems, all I need you to do is tell me if these next 5 problems are the difference of 2 squares. All right, let's take a look. Difference of 2 squares. We're looking for the first term to be a perfect square, the last term to be a perfect square, and separated by a minus. So yes, this is the difference of perfect square, and here is my reasoning. My reasoning is, this is a perfect square because the exponent is even. This is a perfect square because 5 times 5 is 25, and it's separated by a minus. So the answer is yes, and that's the reason. Let's look at this one. Y to 6 minus 2. Well, y to 6 is a perfect square because that's even. Minus, it's supposed to be separated by a minus, that's good. But 2, 2 is not a perfect square. So this is no, because 2 is not a perfect square. All right, ready? 3. X squared, a perfect square because that's even. 4 is a perfect square, but here be the problem. That's a plus. That's supposed to be a minus. It's called the difference of 2 squares because it's got to be separated by a minus sign. So this is no also. No. Here's why it's no. Okay. Let's look at this one. X to the 8th minus 1. This might be a little deceiving. Okay. We look for an even exponent. We have it. So that's a perfect square. 1 is a perfect square. Absolutely. Because 1 times 1 is 1. Okay, and it's separated by a minus, so this is a yes. Okay, this is the first term. That means every factor of the first term must be a perfect square. X squared is, y squared is because they're even. 16 is because 4 times 4 is a 16, and it's separated by a minus, so this is yes. So this is the difference of 2 squares, so is this, and so is this. These two are not. So let's learn how to factor the difference of 2 squares. Okay, here we go. Step 1, look for GCF in all your terms. You don't have it. Can't do step 2, can't do step 3. Go to step 4. Count your terms. There are 2. If there's 2 terms, here's the new rule. You got to go to C, 4C, which says, if 2 terms, check for the difference of 2 squares. This is a perfect square, this is a perfect square, and separated by a minus. So yes, it's the difference of 2 squares. It says, if it's a difference of 2 squares, you're going to obviously get conjugates because conjugates give you the difference of 2 squares. All you do is square root this. So what times itself gives me 9x squared? That's 3x and 3x, which is really what we've been doing anyway. Factor that, factor that. Okay? Then square root the 16, 4 and 4. Since that's a minus, signs are different. So there's your factors. We are done. You don't have to worry about your middle term because what should your middle term be? Yes, it should be 0. Because this is the same thing as saying 9x squared plus 0x minus 16. Your middle term should drop out. Positive 12x, negative 12x drops out, because that's what happens when you multiply conjugates. So my final answer, 3x plus 4 of the quantity times the quantity of 3x minus 4. And it doesn't matter which factor you write first, right? You can put the minus 4 here and the plus 4 here. It does not matter, because they are commutative. All right? That's the end. Let's do some more examples. All right, here we go. 9x squared minus 1. Step 1. Who cares? No. Step 1, look for a GCF. No GCF. Can't do step 2. Can't do step 3. Step 4, count your terms. 1, 2. 2 terms, that's 4C. See, I have this memorized. Why? Because I've been doing this for 26 years. Okay, if you did it for 26 years, you never graduate. All right, at any rate, okay. So, 2 terms, check for the difference of 2 squares. 9x squared is a perfect square. 1 is a perfect square and it's separated by a minus, so yes. By the way, forgot to say I'm sorry. Just as in the trinomial, we want it in standard form, and it is, and we want the leading term positive, and it is. Forgot that. Always forget that. Square root the first term, 3x times 3x. Square root the last term, 1 and 1, 1 plus, 1 minus. I love the difference of two squares. All right, here we go. Okay, step 1, look for a GCF. Yes, there is a GCF. The GCF is 3. But I have a rash. You all know why I have a rash at this point, because that is negative. Don't like it. So I'm not going to take out a 3. I'm going to take out a negative 3. And we get y to the 6th minus 25. Now, here's the dilemma. Not really a dilemma, but something we have to understand. The more we learn, the more we have to do. You may not be done. You may be done, but you may not be done. How do you tell if you're done? You ask for help. No, that's not it. You go inside the parentheses where you see the terms, and you say to yourself, I hope I'm done. No, you say to yourself, okay, count my terms. There are 2. If I have 2 terms, I have to check for, yeah, that's it, the difference of 2 squares. So I look for the difference of 2 squares. That's a perfect square because that's even. That's a perfect square because 5 times 5. It's the difference because of the negative. So I have to continue. I must continue. I must. Here we go. Square root this. What times itself is y to the 6th? It means square root it. So that's y to the 3rd. Remember, you just divide that by 2. Y to the 3rd. Square root 25, we get 5 and 5. 1 plus, 1 minus. I hate to break your chops here, but here's the deal. I may not be done. See, here's the deal. When I have a linear factor, this is called a linear factor. I should have said this a while ago, but I forgot. When I have a linear factor, I know I'm done. But this is not linear. This is bigger than 1. I may still have more to do. So what do I have to do? I have to count my terms. Well, the only thing I know how to do is factor the difference of 2 squares if there's 2 terms. That's not the difference of anything. That is, but these are not perfect squares. So guess what? Yes, hallelujah, I am done. Awesome. That takes care of that problem. Problem number 3. Okay. Step 1, look for a GCF. Can't do step 2, can't do step 3, step 4. You're going to memorize this. Count your terms. How many you have? 2. Check for the difference of 2 squares. Not the difference of anything. So you cannot factor this over real numbers. I know what you want to do. I know you want, don't lie. Don't lie. I know you want to do this. This is not going to work. Why is this not going to work? Because you're going to get a middle term. You're going to get d squared plus 3d. I know I have to prove it to you at least once. Plus 9. You're going to get this middle term of 6d. The only reason it works when it's the difference is because since the signs are different, that middle term drops out. So you cannot factor this. D squared plus 9 is prime. So the answer to this question is prime. I cannot factor that. I am done with numbers 1, 2, and 3. I have 3 left on this slide. All right, here we go. First step. GCF. So we do have a GCF. The GCF is 4. This is the only time we make one set of parentheses when we have a GCF. So here we go, and we get 4x squared minus y squared. Okay? Now, here's the thing. We may be done. We may not be done. How do we know? We go inside the parentheses. We see what we have. We have 2 terms, so we check for the difference of 2 squares. This is the difference of 2 squares. So now we bring the 4 down, make 2 sets of parentheses. Square root this. 2x times 2x, square root this, y times y. And if you'd rather, just like we did before, you can do this, if that makes you happy. Okay? And then 1's plus, 1's minus. Now, I go into the parentheses, but I notice that these are all linear. I'm done. So, done deal. Okay, those are my 3 factors. Ready? Let's take a look at this one. GCF, yes. We take out a 2. We divide by 2. We get 9y to the 4th minus 1. Here we go. You ready? Okay. We come in here. We look to see. And again, I'm forgetting to say standard form, which we have. a leading term positive, which we have. So I am checking, I'm just checking in my head. Yeah, okay. All right, anyway, so we make two sets of parentheses, because we do have the difference of two squares. 3y squared, because we divide that by 2. 3y squared, 1 times 1 is 1. Make 1 plus, 1 minus. This is not linear, we have to check. Two terms, this is not the difference. This is, but it's not the difference of two squares, because 3 is not a perfect square. Y squared is, 1 is, but 3 is not. So you are done there. You have to know when you're done. You are done. If you multiply this times this, you will get here. Then this times the 2, you will get here. So you're always trying to get back to where you were. Instead of writing it as terms, you're writing it as factors. That's what we're doing. It's called factors. That's it. We're factoring. This is one of my favorite problems. It looks almost like benign, right? It looks like it's no big deal. Let's take a look at this. Okay, we look for a GCF. There isn't one. We look for standard form, and this could be considered standard form. This is fine. Okay, and now we count our terms. There are 2. We look for the difference of two squares. Yes, that's even. That's even. Separated by a minus, we have the difference of two squares. So here we go. Okay. Square root this, x squared times itself, y squared times itself, 1 plus, 1 minus. Now, they're not linear. They're bigger than 1. I better go check. I have two terms. The only thing I know how to factor for two terms is the difference of two squares. This is not the difference of two squares because of this. However, this is the difference. You're kidding me. Are you kidding? You're kidding me. This is I love this. This is the difference of two squares. Here we go. So we'll write this down. For this, we're going to have to make two sets of parentheses. Square root this, x and x. Square root this, y and y. Make 1 plus, 1 minus. They're linear. They're done. We're all done. That was awesome. And that's the end of that slide. Now we have a couple problems for you to try. On the next slide and in your workbook, there are 6 problems. You try those. All right, can we fit this on this little board? Let's see. X squared minus 25, we're factoring that. First step, look for a GCF. There is none. We have standard form. Finally remember to say that. Leading term is positive. We're all good. Count your terms. There are 2. Okay, and it is the difference of two squares. So we're going to factor that. And I bet you didn't do that. I bet you just went right to the factoring. You have to remember there are all those steps to be concerned with. X times x is x squared. 25 is 5 times 5. 1's plus, 1's minus. So I am done there. And these are linear, so I'm done. Okay, ready for this guy? We look for a GCF. We have one. 2x. We make one set of parentheses. That's the only time we make one. We divide by 2x, and we get x squared minus 9. Now, we're not sure if we're done. We have to go inside to the terms. There are 2 terms, and they are the difference of 2 squares. So here we go. X and x. 9 is 3 and 3, plus and minus. We are done there. 4 factors, the 2, the x plus 3, the x minus 3. Done. Ready? I gave you easy ones here. All right, 4d squared plus 8. We look for a GCF. We have one. Sorry, I have to divide by 4. Now we have to go inside the parentheses. Because they're not linear, we maybe still can factor this. We check our terms. There are 2. We check for the difference of 2 squares. That's a perfect square. That's not a perfect square. And that is a plus anyway, so we can't factor it. Now, this is your answer. It's not prime. Your answer is not prime. This was not prime. This is prime. But this is my answer. Okay? 4 times the quantity d squared plus 2. So it's just important to know when you're done. Okay? Let's take a look at this guy. Okay. Looking for a GCF, we have a big one, 25. We have 4a squared minus b squared. Totally not linear. So we're going to take a look in here. There are 2 terms. We check for the difference of 2 squares. This is definitely the difference of 2 squares. So we have this. What times itself is 4a squared? It's 2a and 2a. B squared is b times b, 1 plus, 1 minus, and those are linear. You are done. So that takes care of those 4. We have 2 more left. So far we're good. A lot of these had GCFs. Some just numbers, some numbers and letters. So that was pretty cool. All right, let's take a look at number 5. Number 5, look for a GCF. We have one again, y squared. Now this one has just a letter, okay? Divide by y squared. We have y squared minus 9. We may not be done. Look inside the parentheses. We do have the difference of 2 squares. Again, 2 terms. Y squared is y and y. 9, 3 times 3, plus, minus. Okay, we're done now. Those are linears. Oh, look at that. We're flying. All right. 6. Don't let this scare you. All right. 2 terms, no GCF. But checking for the difference of 2 squares. That's a perfect square. That's a perfect square. The fraction is a perfect square. Easiest way to tell, look at the numerator. They both, numerator and denominator, both have to be a perfect square, and they are. So here we go. W squared is W and W. 4/9. The square root of 4 is 2. The square root of 9 is 3. Or what times itself is 4 is 2. What times itself is 9 is 3. So 2/3 times 2/3, and then the signs are different. Don't let fractions make you crazy. You cannot clear it, but it's not an equation, not an inequality. And that's it. That takes care of all 6. I'm going to show you something a little different, and then maybe, kind of, just a little twinge of a difference, and then we'll continue. All right, let's take a look at these. Let's see how they're different. Okay, first thing I want to do here, because I'm getting a rash, but not only is the leading term negative, it's negative, but that's not even the leading term truly, because I have to have this in standard form. So it's 4x squared minus 81. That's what I really want to factor. Now I'm looking for GCF. There isn't one, so I look for a difference of 2 squares. That's a perfect square, that's a perfect square, and 81 is a perfect square. And there's the difference between them, so I have the difference of 2 squares. 4x squared is 2x times 2x. 81 is 9 times 9. 1 plus, 1 minus. I am done. Because these are linear, didn't even check inside. Okay, that's it. And notice they're conjugates. I don't think I said that once, but we talked about it, that these are going to be conjugates, because that's how you get the difference of 2 squares. Okay, now I got to be honest. You could factor it just this way. You could factor this like 3 minus z, 3 plus z. But I don't like it. And I'll tell you why I don't like it. Because later on, especially in intermediate algebra, this is not going to help you. So you could do that. I'd have to mark that right if it said factor. But I'm going to tell you what I'd rather do. Okay? I'd rather put this in standard form. So it's going to be negative z squared plus 9. But now the problem is I have a rash, because the leading term is negative. Okay, so I'm going to pull out the negative 1, and I get z squared minus 9. Now I have to go inside, check for the difference of 2 squares, and I have it. Z squared is z times z. 9 is 3 and 3. And 1's plus, and 1's minus, and now I'm done. And to be honest, when you get to intermediate, this should be more helpful. Though if you wrote 3 minus z, 3 plus z, the quantity 3 minus z times the quantity 3 plus z, I have to mark that right. Let me tell you why that is also right. If you did 3 minus z, 3 plus z. Let's talk about why that's right. 3 plus z is the same thing as saying z plus 3. If I multiply this times this, I really get that. Negative 1 times negative 3 is positive 3. Negative 1 times z is negative z. So it is the same thing, just written a little differently. Okay, that to me is backwards. That's big rash. That's big rash. Not even small rash. Big, big, big rash. Okay, I think I'm hospitalized for that. I'm not really sure. Okay, here we go. All right, so how about this guy? Well, that is standard form, but I don't like it, rash, because the leading term is negative, okay? But there's no GCF, so I'm going to have to try to factor out just that negative 1. And I get 49y squared minus 1. Not linear, so I'm going to check it. 2 terms, I'm going to check for the difference of 2 squares. We do have that. Okay, so I have 7y, oops, forgot another one. 7y 1 is 1 and 1, plus and minus. So these three factors are my answer for that one. Okay? So that might be the easiest way to do that. I have 3 problems left, and I really like these problems. I want to see if we can apply what we know. Okay? Let's see if we can do that. All right? So here we go. These are, you know what I'm going to say, right? My favorite problems. Here, let's take a look at this. Okay. Do not be multiplying here, because if you're multiplying, you're going the wrong way. We are factoring. So remember, this negative tells me that this is a term and this is one term, but this has got factors on this side. I shouldn't say side. Factors in this expression, factors here. So here we go. I'm looking for a GCF, and I have one, y minus 1. It's in parentheses, so I'm going to leave it in parentheses. That's my GCF. So I'm going to make a big set of parentheses. I'm going to divide, see, and this should be old news, by my GCF. When I do that, I get 4x squared minus 9. 4x squared minus 9. Do not walk away. We may not be done. The truth here is this is linear, so that's okay. But this here is not okay. It may not be okay because it's not linear. We have to check it. There are 2 terms. I'm going to check for the difference of 2 squares, and I have it. So I am not done. These can get so big. Isn't that cool? Okay. 2x times 2x. 9 would be 3 times 3, 1 plus, 1 minus. I am now done. That's the end of the problem. All linear, we're good. Good to go. Awesome. Very cool. All right. Remember here that we are not trying to multiply, so I do not want to write this first. I don't know if, can you see what I see? Let's see. It's not a song, can you see? Anyway. All right. Think of this as one term and this as another term. This whole term is a perfect square because the exponent is even. This is a perfect square because 2 times 2 is 4. So this whole thing is the difference of 2 squares. Watch what we're going to do. This is so cool. Oh, you're going to wet your pants. This is so cool. All right, watch this. I make these a little bigger. Okay. We got to say what times itself is going to give me x plus y quantity squared. Well, that's just x plus y. Pretty cool, right? Because x plus y times x plus y is x plus y quantity squared. Now, what times itself is going to give me 4? That's going to be 2. And then what about our signs? 1's plus, 1's minus, just like before. I cannot have parentheses in parentheses, so I have to clean this up. There's a 1 here that you don't see, so the parentheses are useless. So this is just x plus y plus 2. Same thing here, x plus y minus 2. That's how you factor this problem. Okay, so that's it. Totally cool. Totally cool. I know we have another one. We'll get to it. Totally cool. All right. Okay. Let's look at this. Perfect square. We don't want to multiply. Let's look at this. Perfect square. So guess what? We have, again, the difference of 2 squares. Oh, this is remarkable. Watch this. Watch this. It's so big, but you got to be really careful. Okay. X plus y quantity squared is x plus y times x plus y. A plus b, it's in parentheses. I would keep it there. A plus b. What about my sign? 1 plus, 1 minus. By the way, if this was a minus b, that just would have been a minus b, a minus b. It doesn't matter what's in here. We're just having that twice as a factor. Now we have to clean up. This parentheses are totally unnecessary. This, be careful. I have to distribute that negative. So it's x plus y minus a minus b. So sometimes the parentheses are necessary. That's why I put them in here. And if we didn't need them, we just took them out. But this is that is incredible. Look what you can do. Look what you can do. Do you remember where we started in Mod 1? Oh my gosh. Look what you can do. Amazing. And that's the end of lesson, what lesson are we on? 3. That was lesson 3.